Hey everyone, I'm Abby with Spiceworks, and I'd like to welcome you to today's Spiceworks Partner Webinar, Networking is Ready for the Next Generation of Architecture. Are you? Brought to you by M&J Technologies Direct. Before we get started, I wanted to let everyone know that the webinar will be recorded, so if you have to step away for any reason, you will get an email with a link to the video in about a week. Also, we want your questions, so be sure to log those into the question box during the presentation, and our presenter will answer as many as possible at the end. So now that we have all the housekeeping done, I'd like to introduce you to our presenter today. We have Jeff Serbinsky, and he is the manager for the Network Solutions Architect team at HP. So Jeff, whenever you're ready, take it away.
Good afternoon, everybody, and thanks for joining. And I'm really excited about this talk, and it's really because this has been a long journey within networking. And I know that sounds kind of funny saying it that way, but I've been in the networking industry for getting close to 30 years, and if I look back to when I got started, which was back in the 80s at the University of Wisconsin, networking technology was really young back then. And if we look at what was available back then, if you were one of those that were working on stuff back then, there was a myriad number of technologies. There was Ethernet, ArcNet, Token Ring, Local Talk, Apple Talk, there was different operating systems, Banyan Vines, Novell NetWare, IBM OS2 LAN Manager. There was just a lot of stuff going on. There was a lot of experimentation. And once, we found out what worked, we found out what didn't work. And in the 90s, when we got there, we really realized that, hey, we don't need this many choices. We can settle in on a couple of good technologies that work really well. And those two technologies were IP and Ethernet. And as we exited the 90s, that was what everyone was switching to. They were ripping out, Token Ring, ArcNet, City. They were ripping out failed experiments with ATM Lane, and we were all going to IP and Ethernet. And then we got into the 2000s, and we felt pretty comfortable with those decisions we made in the 90s. But what we found out was that us manufacturers got a little too comfortable, and we let you down. And if you look back over the 2000s, we really didn't do much innovation. All of the innovation was really about giving you new boxes that did most of the stuff the boxes that we sold you before did. They were bigger, they were a little bit faster, they might be a different color, different form factor, but essentially it was IP and Ethernet, not a big thing. And that worked well. There's nothing wrong with that. I mean, that's the networks that we have today. But the applications and the way our users want to use those applications are changing dramatically. We have an instant on group of people out there, our customers, our partners, our employees. They expect new functionality, they expect it really quickly, and the networks that we have to build today have to change very rapidly, and that old architecture is not going to work. And I'm not suggesting that necessarily IP and Ethernet go away. Those are two really good things, but really how we architect networks should really change, and that's what this talk is really all about. So as we try to keep up with those changes, there's three really big trends out there. So the first is simplification. And simplification really needs to happen because if we're going to roll out brand new networks, if we're going to change up how people connect to the network, if we're going to potentially have networks that sprout up and disappear quickly because of changing business needs, we have to have networking products and architectures that are easy to roll out and also take back home. The other area where we're seeing a lot of requests for help is in orchestration. So the network is just one aspect of it, but if we're rolling out a new application, that means that there's going to be servers, there's going to be storage, there's going to be a network, there's going to be some support options in there to support all that. And orchestration is where we can get everybody in harmony together, where we have the ability to roll out a brand new application and do it consistently every single time. And that would be the configuration of the optimization of server, storage, and network together, saving our customers time in terms of rolling things out and doing it the same way every single time. And then lastly, one of the biggest trends out there is this trend of virtualization within the networking space, and that's where I'm going to spend the majority of my talk talking about, is within virtualization. But before we jump to that, I wanted to hit one point that one of the analysts have come out and made, which is Gartner, and they do a rather popular service and a rather popular way of looking at the industry. It's something called their Magic Quadrant, and it's a measure of ability to execute versus completeness of vision, and they do that against the X and the Y. And if you end up in the upper right-hand corner there, that means that you're a leader, right? It means that you have great vision and you can actually execute on that vision. Two different things. And what's really weird about this Gartner Magic Quadrant, which came out in February, is that Gartner put nobody there. That was pretty darn interesting. But if you take a look at it, and certainly one of our prime competitors does have great ability to execute. But Gartner didn't think they had great vision. And if you take a look at where HP is at, we're actually we're as far right as anybody within the vision category. They rate us quite high, and I think what's happening and what you'll see happen is that HP, through a lot of its innovative networking technology, some of which I'll talk about today, will prove out that we can execute. And so we're really excited about that. We're really excited about the fact that people like Gartner and other organizations are taking note of what HP is doing in networking. With our networking vision. So we have a polling question for you. Are you surprised to see how Gartner views the marketplace? If you could, select an option there and hit submit. Okay, all right. So here's some of the responses we've got in so far, and actually seeing that some of you guys actually are a little surprised, some are not. It's a little bit more yes than no there. So I'd have to say I was quite surprised. I think a lot of people would have thought other companies might have been up there in the leader quadrant. All right, so let's talk about some of these solution trends. There's three of them that are driving virtualization in totality. So the first one, we'll talk about each one of these. The first one will be network virtualization, also sometimes referred to as hardware virtualization. The next one we'll talk about is layer 2 fabric technologies, of which there's quite a few. I'm just going to talk about one of them. And then software-defined networking, a new topic that's coming up quickly and is in all the press lately. And we'll spend the most amount of time on SDN. So each one of these technologies tackles a set of problems. And if we look at a standard network, the one picture here is one of the data center. Showing a very classic architecture, 3 tiers, a core, a distribution, and an access layer, and then servers attached to it, whether they be rack or blade servers. And typically in modern data centers today, we want to have the ability to do quite a bit of things, right? We want to be able to have security potentially between devices. We want to definitely provide different network services, whether they be load balancing or IPS, things like that. But one up-and-coming thing that we've been having to give to servers to support new applications is layer 2 connectivity between servers. Could be because of VMware, so we can do vMotion. Could be because of fiber channel over Ethernet, because you're using that as your storage technology. You could be using a load balancing application that requires multicasting of a layer 2 MAC address. But what that means, if you're going to do those things, is that you need to have layer 2 between any one of those access layer switches and each other. And to do that, often we've turned to a lot of legacy protocols to do that. So one of those legacy protocols is spanning tree. It allows us to run layer 2 between multiple switches. It works by taking out loops inside of the network. And it's interesting, it's a fairly old technology. It wasn't designed for the size of networks. It wasn't designed for the speed that we'd expect the network to converge. It certainly figures out the loops in the network, but when something breaks, it takes quite a while to actually recompute and reconverge the network so that we figure out the new path. Increased convergence in the data center network is not a good thing. We don't want switches blocking traffic while they figure out what the topology is. We want it to reconverge really quickly so our apps can run. We also have to use protocols like VRRP or HSRP to give us router redundancy in these types of networks. Those also are timer-based, and they can actually, increase the convergence time if, say, a routing entity goes away. So this really gives us decreased resiliency within our data center network. Not a great thing. The other thing we also get with this multiple tier network is increased latency, right? Because of these multiple tiers. Every time I have to take traffic through a switch, it takes time to move that traffic, and therefore it creates latency. And oftentimes, in modern application architectures, we have federated applications. And what that means is that the application isn't monolithic. It's not sitting on one server. It's usually sitting across multiple servers. So you might have a web UI server. You might have a logic or a business logic server. You might have a database server. You might have a block or file server that's involved in it. So a lot of times, and in most data centers with most applications, there's a lot of traffic. Vast majority of the traffic is actually server to server, and only a little bit of it goes back to the user. So having increased latency between all the servers really slows down the applications. Obviously, we have a very thick multi-tiered network that's going to increase management, and as well, getting back to layer 2, via mobility can be interesting in a larger data center because of using these older protocols. So in comes network virtualization or hardware virtualization to solve the problem. And what that is it is technology that allows you to cluster together multiple network devices, whether they be switches or routers, so they combine into a single entity. Maybe an older word that you might have heard in the past, or some people still use it, is stacking. That's probably a little bit older, less mature type technology. But this network virtualization technology, it actually allows us to cluster together boxes. They cluster together at the hardware layer, or the kernel layer of the operating system, and they form a single box. And they can do both switching as well as routing and any other advanced functionality. HP's got a very much leading technology called Intelligent Resilient Framework, or IRF, that allows us to do this clustering. Well-proven technology, been out for the last 10 years. And one thing that HP did that's really innovative is we use the same technology across our solution set. So I can actually give you campus-based switches that I can IRF together. I can give you campus-based chassis switches that I can IRF together. And I can give you data center access distribution and core layer boxes that can IRF together. So I can use the same technology both in my campus or in my data center. We also support clustering and routers as well, so we can actually cluster together routers. When they're clustered together or IRF together, they're a single operating system. They have a single configuration file. They have a single IP routing table. All the same features are there together. And so they become a single box. I also manage that new box, this clustered box, as one entity. So we actually support doing that with up to 4 chassis and up to 10 stackables or 10 blade-based boxes as well. So in our HP C7000 blade system, our 6125 XLG blades, it's Ethernet switch blades, and that chassis can be stacked together as well, clustered together to become one unit. What you end up having is less devices to manage. You end up with the ability to take out loops in the network, which means that you can get active-active connections. You can remove spanning tree. It works for routing as well, so I do not need to use VRRP or HSRP. It also inherently gives me in-service software upgradability. So when I go to upgrade a cluster of switches, I can take one down, upgrade it, leave the other ones up and running. I obviously lose a little bandwidth while I'm doing that, but the network still works and still delivers traffic while we're doing that. So it's really a great solution. And we have it installed at many, many, many large data centers and very large campus networks. So just hitting up the benefits again here. Network virtualization gives you faster convergence. One of the things in the last slide there, we actually advertise that we can actually give resiliency of a cluster of boxes within a solution set of less than 50 milliseconds. And actually, in most of the scenarios, I can actually set it up so that resiliency is less than 1 millisecond. You can actually go up to a chassis-based box. Maybe it's part of a 4-chassis cluster. I can actually turn the entire box off, and you'll have less than 1 millisecond convergence in that solution set. If you compare and contrast that to a lot of the legacy protocols like spanning tree, you might be down in terms of seconds when that happens. So we have faster convergence. We increase the resiliency. We can decrease latency because we can actually make the network thinner. Because if I can cluster boxes together into a single giant switch, I'm going to end up needing less switches. I can reduce and take out a lot of legacy protocols. I also decrease the management because I'm managing less boxes now. I'm managing clusters of boxes. DC scalability goes up, and VM mobility is a lot simpler. Really a great technology. We really suggest it in all of our customer designs. But there's other technologies out there, so we'll hit up the second one here. So if we look at a data center network again, it's going to have multiple tiers just like the last one. We're going to have the same issues, right? We have to run spanning tree if we want to do layer 2. We have to run HSRP or VRP for layer 3. We might have to build out the network with multiple tiers. So we have a lot of the same issues. Increased convergence, decreased resiliency, increased latency. One thing I didn't mention before is you have unused links when you use protocols like spanning tree, because what it does is it shuts down loops in the network. And when you shut down loops in the network, it means that you've paid for ports. You've paid for network bandwidth that you cannot utilize. And one thing that's really interesting too is that you can pull off having a fairly stable data center network that runs spanning tree and that utilizes most of the bandwidth available. There's a lot of different architectural ways that you can do that, but one thing I'll really say is that protocols like spanning tree are really simple protocols. And even though you can do some interesting things with them, the configurations are really complex, and they really never were designed for it. It's really unnatural for them. So there's been a bunch of technologies that have popped up in how to deal with that and how to fix and rip out spanning tree. And one of those technology choices that has been ratified fairly recently is one called TRILL, or the transparent interconnect of lots of links. And what TRILL is a protocol that instead of taking the loops out of the network, it routes layer 2. So it seems a little odd saying that at first, but essentially it uses the ISIS routing protocol to actually route layer 2 traffic between nodes. What it means is that I can get active-active, I get the ability to use online links, and the neat part about it too is it's standards-based, so I can interoperate with anybody else that's running layer 2 with TRILL. Can build very large data centers. So one of the neat things I can do with it, I can give you faster convergence with TRILL. I can increase the resiliency. I can get multipathing out of this network. That's really key, obviously. If I'm going to buy ports, if I'm going to buy devices, I want to be able to use all the network bandwidth I have available to me. It simplifies things like vMotions, because I can actually provide layer 2 between any point in the network. I can get great scalability. We've actually designed out data center networks using TRILL that get into tens of thousands of servers connected, physical servers. So it really gives you great DC scalability. Nice protocol. So let's jump to the next one, which is software-defined networks. So we still have some of the same issues we talked about, but let's look at things from a different angle this time. So if you think about our standard networks today, we have multiple devices, and we manage all of those devices individually. Each device has its own operating system, its own configuration file, and each device actually does a lot of the same features and functions. It figures out the topology of the network. So if it's a layer 2 switch, it typically uses spanning tree to figure out the topology of the network. If it is a routed network, it's using a routing protocol like OSPF or BGP or ISIS to figure out the topology. And what's kind of interesting, I think, is that networks are built today with kind of a very old-fashioned mindset. And that old-fashioned mindset is that every single one of the devices has got to figure out the topology. And I really find that quite strange because for all you guys on the webinar here, if I asked you to give me directions, say from Chicago to New York City, and I asked you to do that without having a map, and I asked you to do that without having a GPS, you all can do it, but you probably would come up with a different way to do it every single time, every single one of you. Some of you would actually write down the names of roads. Some of you would write down the names of freeways. Some of you would write down landmarks. Some of you might actually give me the timetable for a bus or an airplane flight. You wouldn't do it all very consistently. And that's I think that's kind of weird because that's the way networks work today, is that every single device in the network figures out what should be the same thing, the topology of the network. And the topology is the topology. Things are set in stone, but that's the way we design networks. And I think if you all think about it, that has been one of the complexity items that we've had with networks, is that sometimes they don't do it right, and sometimes they don't tell each other what they know about things very right. And that creates lots of networking issues, whether it be on layer 2 or layer 3. You could probably say that too with other advanced features like QoS. If anybody in the audience has ever implemented voice over IP or video conferencing, you know that it's hard to implement QoS and do it in a very consistent way. So in normal networks today, I'll say that it's like we have increased management, we have protocol complexity, protocol compatibility issues, especially when you mix in different vendors or even the same vendor. A very popular networking vendor out there has multiple operating systems and therefore has multiple different ways of doing things and multiple bugs. Orchestration gets really complex too because I can't tell one device, I can't have a server or an application request something of the network because there actually isn't an entity called the network. There is multiple entities, switches and routers that comprise the network, but they're not really the network. They're kind of like, they're all loosely coupled. So we really need a new way to actually take a look at the problem. And that's what software-defined networking goes to attempt to do. What it is a standards-based approach for changing up the way network devices work. And if you look at a standard networking device, this could be a switch or a router or a wireless access point, a firewall, a load balancer. It has two components. The first component is the control plane. And the control plane is where all the features run. It's where the decisions are made on what traffic to switch or route, whether to block it, whether to forward it, whether to give it a high priority or low priority. All that stuff is figured out there in the control plane. And then the data plane of the box is actually what does the heavy lifting, the ins and outs. It essentially follows the rules that the control plane sets forward. And so what software-defined network attempts to do and does do is take the control plane out of every device and put it in a central location. And if you think about that, super efficient. It means that I figured out the topology of the network once, and I tell all the data planes to actually forward it. So that's really neat, and we'll talk more about that. The other thing it does is it separates features away from the data plane. So features like QoS, features like topology, features like fiber channel over Ethernet, features like the ability to understand voice and things like that. Whatever that feature might be, we separate it and we actually make it into something that looks like an app. It allows us to instantiate services across the network so that those services are actually running in multiple points. And we'll get into that in a little bit. So there's a lot of benefits. If I can actually separate the control plane from the data plane, I can configure a network in a single place, giving me simplified configuration. It also allows me to manage in the same place. As well, since I have one place managing all of the data planes and understanding how everything's connected to the network, it means I can do all kinds of cool stuff. vMotion is simple. Orchestration, it's really simple. There actually is now an entity called the network, and I can actually tell the network something to do. The network can still be made up of hundreds of data planes, switches and routers like we call them today, but I can control it in one spot. And of course, then I can get great scalability, whether it be in a data center or a campus. So there's a lot of great benefits to it. So if we compare and contrast these different technologies, because some of them actually tackle a lot of the same things. All these technologies get rid of spanning tree. All of them fix issues with multipathing. All of them can give me active-active configuration, forwarding. All of them can help me with VM mobility. They can even be complementary between each other. I can do network virtualization and SDN, or network virtualization and TRILL together, which is really great. But there's a couple things that really stand out. So within the layer 2 fabric technologies like TRILL, it doesn't reduce the management. All it does is it gives me a new way to move layer 2 traffic. And it doesn't give me reduced configuration because I still have to manage all the devices. It just changes the layer 2 forwarding. But one thing that's different, and SDN stands out, is it gives me applications, network applications. And I'm going to give you guys a bunch of examples here in a second on those. So let's start off with going back to what I was saying before, with this definition of SDN. So in an SDN architecture, we decouple the control plane from the data plane, and we centralize it. And it allows us to actually abstract away the underlying network infrastructure and virtualize up network applications, as well as give me new applications that allow other entities to tell the network things to do. So these are really, really key points. So I always love going back to history because I truly believe that you can look back and you can find the analogs to a lot of solutions to a lot of problems. And if we go back to the 90s and I think back about server architectures, and I think back about companies like IBM and HP and Digital and Tandem and lots of other ones, they all did the same things. They all gave us IT solutions, but they were based upon proprietary server architectures with proprietary operating systems running proprietary applications. And it means that if I liked DEC, I was stuck with DEC for the whole stack. And HP really did a really brave thing back in the 90s, and they said, we don't see the industry growing unless we change things up because we already hear that our customers don't want to buy the operating system from the same company that gives them the hardware. And they certainly might not want to get an application from that same company either. So we invented the whole concept of industry standard servers, the ability to have a standard Intel-based box built in a fairly standard way with a standard BIOS that can run multiple different operating systems from multiple different companies or even from open source. And they can run apps that you bought, apps that we sold you, apps that came open source. And it really drove a lot of innovation. And it really, 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 if you think about HP, I mean, back in the 90s, we were less than a $20 billion company. And, doing the right thing for our customers, that grew us from this less than $20 billion company to a $130 billion company that we are today. And ISS was probably the strongest thing that did it. And we truly believe that the same thing can be done today with networking, because we have the same thing. We got proprietary hardware, we have proprietary OS, and we have features, these things I called apps before, that are glued to the box. And if you want a networking component, a switch or a router that does something new, a lot of times you have to go and replace the hardware to get it, because the hardware is married to the OS, married to the features. I can't just add an app to a switch. People haven't done that. And so we're going to do the same thing, and SDN is exactly how we're doing it. So we're going to give you guys standard programmable systems, right, whether it be devices that look like switches or routers or wireless access points. We're going to give you a centralized control plane where essentially the network operating system runs. And then we're going to take network features, topology, QoS, voice and video features, and make them apps. And those apps can be added and taken away. And we really think that there's going to be a ton of innovation with this. HP is really leading the way in this space. And even though some of you on this call might not have ever heard about SDN before, we've been working on it for quite some time now. Back in 2007, in fact, where we did our first experiments with Stanford University. They had a project called a FANE, and a FANE was this exact concept of taking the control plane, separating it from the data plane. But the initial things that they did were all in software. They used a vSwitch. They used a virtual controller. They had virtual packets and virtual hosts. And they came to us and they said, can you help us out? We want hardware. We want to do this in the real world. And we gave them some of that first hardware. And that hardware was essentially taking existing switches we had, giving them some alpha code. And the experiment, flourished. And more universities chimed in. And then eventually it made it out to other organizations, to the point where HP said, hey, we just can't give customers just switches that do SDN. We need to give them controllers and applications. And that brings us to about where we're at today. So you have to do, if you're going to do this, you've got to do it the right way. You have to do it with open standards. So the protocol that Stanford initially worked on and then collaborated with a lot of people on ended up being a protocol called OpenFlow. And OpenFlow is a protocol for a controller, the control plane, to talk to a switch or a router or an access point, the data plane, to be able to tell it how to forward traffic. And literally what it does is it tells it, it gives it flows. It gives it flow information. So these would be pattern matches that go all the way up to layer 4 in the IP stack that say how to move traffic. So it can give it a layer 2 flow, give it a layer 3 flow, and give it a layer 4 flow. And it gives a lot of flexibility. And by having a standards-based protocol for the control plane and the data plane to talk, it means that I can switch out either the control plane or the data plane to whatever vendor makes sense, or whatever system makes sense. And there's nothing that says that it can't be a switch or a router or an access point or any kind of networking device. It really simplifies things. And we really feel very strong about the fact that it has to be open standards. Otherwise, you end up locked in with a single vendor. So we've been doing a lot of work with it. Like I mentioned, we work with Stanford. We've also worked with a brand new standards body that came out of the OpenFlow movement, and that's called the Open Network Foundation, or ONF. And I have to tell you guys about it for a couple seconds here, because the ONF is something new and strange within the networking industry. So if you look at all the protocols that we have today, they're either standardized by the IEEE or the IETF. Both of those organizations are run by manufacturers like HP and Cisco and Brocade and Juniper and on and on and on. And there's kind of an issue with that, honestly. The fact that it's us manufacturers that tell you customers what you think you should do. So when they decided to standardize the OpenFlow, they didn't want to do either. They wanted to keep it a community and a customer-oriented protocol. so they could drive the innovation. And the ONF is exactly that. It's run by customers. So in there, you'll see people like Stanford, Google, Verizon, other universities and other organizations. You see us in there as well. You'll see companies like HP. We were a founding member, but we're a manufacturer, so we actually have different rights. We don't have the ability to vote like customers do. They actually determine what happens with OpenFlow. We find that really exciting and really fresh. So if we take a look at how things are going to be built out, as I mentioned before, we're still going to have the infrastructure layer. They're going to be open, standard-based, programmable pieces of infrastructure. The control plane, or also called a controller, will actually be separated from the two, and it will run somewhere within the network, but separate from the device itself. And then features will actually be separated as well. And these features can actually be run on a controller, or they could run at a different spot in the network that actually talks to the controller and gives it information. So these network devices, whether they be switches, routers, or access points, we'll talk to them via OpenFlow. And then we'll have programmable open APIs that will actually let us talk to applications. They can be network-oriented applications, or they can also be business applications. And that's really kind of interesting and different. So HP today is actually shipping a total of about 55 Ethernet switches that actually run OpenFlow. We just announced this week at Interop that we're also shipping 10 new router platforms that also talk OpenFlow. HP announced in May at the last Interop that we would be shipping this month, October, our first SDN controller available as an appliance or a virtual machine, and a series of applications that both we wrote, partners have written, ISVs, or some apps that are actually coming out of some of our customers, and I'll talk about some of those. But the entire stack. But even though HP is offering everything from infrastructure to control layer to application layer, we still allow you choice because it's open standards. There's nothing that says that you can't use a third-party controller or an open source controller or a third-party app or an open source app, or even mix and match our network switches with other network switches. As long as they talk the same version of OpenFlow, they work together, which is really exciting and changes up networking. Here's where I think changes up networking the most, and this is in the area of applications. I'm really super excited about this. So the features today that you have in your switches and routers are set in stone. With our controller architecture, we're actually now going to actually have and launch, we announced it just this week at Interop, an SDN App Store. So this will allow you to go to a safe place, peruse apps that are available that you can put onto your network, and purchase and download and install those apps on your controller and be able to run them immediately. Some of these apps, like I said, will be HP apps. Some will be from third parties, and some will be from customers just like you that give them out to the open source community. So really what we want to do is we want to create an open ecosystem for everybody to join in and give you guys network functionality. We're working with a ton of companies, Intel, Microsoft, SAP, Riverbed, F5. You see the whole list here. There's quite a bit. We're also opening up a whole developer community where you can get access to tool sets to allow you to build new apps. Let's walk through some of those apps right now. So one of the first apps that's out there is the HP Virtual Cloud Network application. And what this is an orchestration app. It allows an IT organization to either deliver to itself or to its end users the ability to roll out applications. And this ability to roll out applications means that when I say that I would like a web server for my own utilization or a SharePoint server for my own utilization, I can actually go into this app, click that I want a certain server type. What the app will do, it'll ask the hypervisor layer to actually deploy that server, ask for some compute cycles, go to the storage, allocate some storage, and then go to the network and ask the network to provide connectivity for that server out to end users. And it orchestrates all of it. Really, in this day and age of application sprawl, of server sprawl, we don't really want to touch the building of all the servers. We can really make it one touch, and we make it very easy. We can focus in on bigger and brighter issues. Another application that's out there is the Sentinel Security app. This is also an HP app. And it's an app that's focused in around instantiating a feature that really can be utilized across our entire network infrastructure. And that's a feature that will help us out with intrusion prevention. And let me give you a little diagram here to show you what that looks like. So if you look at a standard campus-based network, you're going to actually have that's running SDN. So it's still going to have switches, it's still going to have access points. Now it's also going to have a controller that controls the network along with apps. So one of the first flows that controller gives down to the access points is a flow that says, if you see a request for DNS, TCP port 53, please redirect that traffic towards the Sentinel application running in the controller. So that way, if a user down here goes to a website, pingserver.info, it'll actually redirect that DNS request up to the controller, where it'll actually take a look at it. It'll cross-reference it with a database that's updated every 30 minutes that has 700,000 plus bad locations on the internet, the bad neighborhoods, the places not to go to when it's dark at night. And these places where you say, okay, if I go there, I'm going to get a virus, I'm going to get a bot, I'm going to get malware. And so pingserver.info is a known bad place to go to. You don't want to associate it. So what the controller then does is then sends down a rule dynamically, a flow table entry that says block anybody going to pingserver.info. So that user then is blocked from actually going there. And the neat thing about it is that I've now distributed out every switch in my network helps with IPS. Every access point in my network helps with IPS. And if those devices are across the WAN, that actually saves me bandwidth. It's a really exciting thing. Okay, so next app is an app that one of our customers actually designed and deployed. And this is for CERN. This would be the organization in Switzerland that actually does subatomic analysis of particles. And they're looking for the basic building blocks of the universe, and they have a large collider. And essentially what they do, whenever they light up the collider and they blow something up with it, is they're looking for data. They have millions of sensors around that ring. They're looking for pieces of data. So it also means that when they essentially collide, they have billions of data points. So the biggest thing they got to do is collect those data points as quickly as possible. Otherwise, they lose data, and if they lose data, they can lose their next great discovery. And so their issue really was a load balancing issue. They needed to load balance all of these data points and be able to get them into multiple servers. So the app that they wrote actually turns all of the Ethernet switches in their network into load balancers, so they can load balance that traffic and get it to all the servers and save the data as quickly as possible. Really exciting app, an app, again, that a user created. We're really excited about that. So let me ask you guys a question here. Which app sounds the most intriguing? Now, I only gave you 3 apps. There's going to be a ton more apps out there. But out of the 3 apps, what sounded interesting? And while you guys are answering that question, I'll throw out other ideas for apps. There's tons of them out there. There's a lot of neat ones. There's app ideas that take a look at modifying routing tables based upon time of day, so that you might actually switch compute loads from one data center to another data center on the fly. And this is actually an app that's running out there today. Google actually uses it live today. They actually load balance traffic using OpenFlow in their network right now based upon traffic loads. There's actually apps that take a look at where the cheapest place is to run compute out of from a power perspective. So, today you might be running a certain app in New York City, but turning 3 o'clock in the afternoon, it might be cheaper to run that app in a data center running in Singapore. So with SDN, I can actually on the fly say, I'm going to reroute the traffic towards compute sitting in Singapore. And then maybe reroute it to Los Angeles at another time where power loads are cheaper. Tons of apps. Network apps don't have to be network apps any longer. They can actually tie to other applications within the network. All right, so let's take a look at it. Let's see what the answers are. Yes, look at that, the Sentinel Security app. I'm totally not surprised. It's a problem that all of us have, and people have this problem all the time. Matter of fact, a really interesting story. We gave alpha code to a school district in Australia, in Queensland, and they loved it so much that they ran it in production, and we actually can't get them to turn it off. We couldn't get them to turn it off so that we could give them upgraded code because they became so dependent on this app, and the fact that he was able to block in real time students going to bad places. It's really a great app. I think it really applies to anybody in either the data center or in a campus network. So one of the things I want you guys to have is takeaways. Don't get lost in myths about SDN. It's not about implementing network functions in software. It's not about taking a router or a switch or a firewall and running it on a server or a PC or a virtual machine. It's really about utilizing the things that are good about hardware with the things that are good with software together. One thing it's definitely not, it's not programmable proprietary APIs. You want an open standard. You want to be able to switch out vendors. You want to be able to have one vendor be your control, one vendor be potentially your network. But honestly, you might also want to have one vendor, and there's nothing wrong with that. I mean, if HP can be that one vendor, we'd be happy to. If there's other vendors that can do it for you as well, but having an open standard gives you guys choice, allows you to change things up. And then lastly, it's not the end of hardware innovation. It's not that everything's going to switch up to software. We still need hardware. We still need wireless access points. We still need switches. We still need things to connect things to. They're not going to be servers and PCs and virtual machines. In fact, we think that you're going to have a lot of choices in what kind of open flow switches you buy. You might buy switches that are lightly open flow optimized. You might have ones that are highly open flow optimized, or can handle different amounts of flows, low amounts of flows, bigger amounts of flows. So there's going to be a lot of hardware innovation, even with SDN. So really, here's what we recommend to you guys today. You don't have to implement SDN now, but what you should do is simplify your network, and you can do that with a lot of different technologies. There's a lot of great orchestration software out there. One solution set that I suggest you take a look at is HP's Intelligent Management Center, which can provide orchestration between your hypervisor layer and your network layer, as well as HP's One product, which allows you to provide better connectivity, better orchestration between server, storage, and network. We really suggest a two-tier network. We suggest network virtualization. Those are good tried technologies. We really also suggest that if you're going to do any refreshes in your network today, pick products that are SDN capable right now. And like I said before, we're highly committed to OpenFlow and the open standards movement. We have 55 plus switches today that run OpenFlow, 10 routers, and more products coming out every single day. And that really future-proofs you guys. You don't want to be 18 months from now going, I'd really like to light up SDN, but you implemented the wrong hardware for it. So if we could ask one last question to you guys as we close up here. Where could you see using SDN first? I'm kind of curious. Would it be in your campus? Would it be in your data center? Or would it be in your WAN? So think about that and click here. As well, while you're answering here, we're going to have the ability to do Q&A here. And I'll have the ability to answer those live here in a second after we finish up this last poll. So I'll just give you a few more tick-tocks of the clock here as folks answer that last question. And if you do have, or the last poll, I'm sorry. And if you do have any questions, you can submit those now, and we'll try to go through as many as we can. All right. I'm going to move over to the poll results. All right. I'm kind of surprised. WAN being the winner there. I'm kind of torn. It's all based on, I guess, who's on the call here. We're seeing customers in both data center and campus get really excited about. So, all right. Well, I'm glad I asked. That was really good. So, Abby, if you're ready, I think you have the questions. We can go ahead and go through those.
Absolutely. So we have one that came through that said, why would an enterprise business choose to use IRS? IRS.
Oh, all right. Great question. Network virtualization. So we have a lot of enterprise customers using IRS, and the reason that they do it is the resiliency part of it. The neat thing I can do with IRS is I'm clustering together multiple switches or routers together, and I'm doing it for resiliency, right? Because I can actually, in an IRF situation, I can use a link, I can lose a piece of cable, I can lose a transceiver, I could lose a line card, I can lose a power supply, I can lose a whole switch. And if I'm redundantly connected to at least 2 switches, and like I said, I can actually go up to 10 switches if I wanted to, that I can redundantly connect things together, that I'm just losing one part of the link, right? And I'm going to keep up and running with the redundant links, with the redundant boxes. And a lot of our enterprise customers really value resiliency. And they want resiliency to happen. They want it to be very easy, and they want it to happen very quickly. And those are big reasons. Good question.
Okay, and then how feasible is this for an SMB?
Oh, that's also a really good question. I think an SMB is actually is one of the perfect places to do this at. Because if you think about it, if I go into some of our smaller customers, and they have smaller IT organizations, I meet with them all the time. Oftentimes, the person that I'm talking to that I think is the network administrator, sometimes also is the server administrator. Sometimes they're also the storage administrator. Sometimes they might do some other things there as well. They have hard jobs. They have to know a lot of technologies. So if I give you a way of managing your entire campus network from a single box, that saves you a lot of time. That means that you can work on other things. If I can allow you to manage your data center from a single box, same thing there as well. I can work on harder problems. So I think SMBs are going to really love this. And by the way, let me give one example, and I should have done this earlier. So wireless technology over the last few years changed up from this exact same way. Originally, when we deployed access points, they were autonomous devices. You had to configure them all individually. But as wireless grew and we had a lot more access points, manufacturers came out with the idea of having a controller to actually control the access point, so I could actually manage all my wireless from one single point. This is really just the rest of the network catching up and doing it in a standards-based way. So I think it's really feasible.
Okay, and then kind of going back to that first question about why would an enterprise business choose the IRF, there's a secondary question with that, and it said, how can a network have redundancy on wired connections without a network loop?
Sorry. Nope, you did it perfectly. It's a great question. So the standard way to do it is actually just using standard link aggregation, LACP. So I can have a cluster of switches, and if that cluster of switches, we'll keep it simple. Let's say it's 2 switches. Since those 2 switches become one switch, I can actually run LACP, one link on one switch, one link on another switch, to another switch, or to a server. And we'll just use standard LACP to actually figure out that the link was lost and route the traffic over the single surviving link. Works for 2 links, will work for 4 links, will work for 8 links, depending upon the hardware. And so that's the way we do it. And the neat thing about it, too, is that the device that you're connecting to this clustered IRF switch doesn't have to be an HP device. It can be anything. It can be a server from IBM, a switch from Cisco. It's standards-based way. You're just talking to just a bigger switch. Good question.
Okay, and then do you see customers writing their own SDN applications?
I do. We absolutely. Good question, Abby. We absolutely do. Matter of fact, I'm working with my team is working with a number of customers right now that are early adopters. Now, some of them are the usual suspects you'd expect, and you would not be surprised of, like several universities, like Indiana University, like University of Kentucky, like Illinois University. They're folks that we're working with. They're building their own SDN apps. But we are also working with enterprise customers. A very large healthcare customer here in the Midwest wants to actually build in hooks between their business apps and the network. A large bank that we're working with here within the Midwest, they're doing the same thing, and they're all very excited about having their business applications talk to the network and request things. Request that the network gives them good QoS or good security. So yeah, absolutely. And if you start to Google the apps that are out there, you'll see that there are already dozens of apps that are actually out there already, and there's hundreds, if not thousands, of other app ideas. It's really quite exciting.
Okay, great. And then one last question, and we'll wrap it up. When do you expect customers to start to move to SDN?
That's a good one. We are already starting to see our customers that are okay with early adoption doing it right now. We've actually have a number of customers that are, I would call the super early adopters, that are running it. But we're starting to get the normal early adopters popping up. There's now a full stack of solution sets from companies like HP. Like I mentioned before, we have switches and routers, we have a controller, we have some apps, and we're starting to launch the App Store here shortly. And so you'll start to see people, I think we're going to start to see it in earnest in 2014. You're going to start to see a lot of folks that'll start to play with it. I think I'll see a lot of folks that will feel very comfortable with lighting it up within their campus network. Only the customers that have cutting-edge applications where they need a lot of orchestration will start to light it up within data centers. That's why I think campuses will probably be the first ones that will make a ton of sense. It'll feel natural and easy because you already did it with wireless. Now we're going to do it with wired, and you're going to do it in a standards-based way. So.
Okay, great. Well, that is it. So, Jeff, thank you so much for presenting today, and I'll let you wrap us up.
Great. Thanks again. We really appreciate you guys. And please reach out to either your HP representative or your sales rep at M&J, and we'd be happy to talk to you guys more about this.
Thanks, Jeff. And just a reminder to everyone on the line, you will get an email in a week with a link to the recording, so definitely be on the lookout for that. Thank you, everyone, for attending today, and hope to see you on future webinars.